in this lecture we will understand the YouTube differential manometer. So suppose there is a pipeline here and there is another pipeline, and if you want to calculate what is the pressure difference, so consider here the pressure is P1 and here the pressure is P2. Okay, and connect, so we connect the YouTube manometer, YouTube differential manometer in between this pipeline. Okay, so let's try to understand how to calculate the pressure difference P1 minus P2. So when you add one YouTube manometer, then the manometer deflection will be there. Okay, so this is the manometer deflection, this is y, distance y, and here the deflection y2. Okay, so here there is water, density of water, that is rho, there is another fluid, the density of the fluid consider that is rho 2. Okay, and here the density is rho 1. So let's try to solve this question. So here the pressure that is P, so going downside, so this will be positive, so rho 1 g y1, because here to here the distance is y1, so plus rho 1 g y1. Okay, so here and here the pressure will be same. Okay, so from here to here you have to go from here to directly here. Okay, and going upside, so that means the sign will be negative, so minus, so here this is the density of mercury, that is this density of mercury is there, manometric fluid, so rho of m g into y minus rho 2 into g into y2, that is equal to P. So from here you can get P1 minus P2, that is equal to rho m g y minus rho 1 g y1 plus rho 2 g y2. Okay, so in that way we calculate the differential pressure. Okay, with the help of YouTube differential manometer. Now let's try to understand there is another topic, that is the inverted tube manometer. So this is also important, inverted tube manometer. So this is one pipeline, the pressure of that pipeline, that is P1, consider this is P1, and here there is another pipeline P2. So here the density is rho 1, here the density is rho 2, and there is a manometric fluid, and consider the liquid manometric fluid deflection, that is y1, and here the distance is y2, and here to here the distance is y1. So P1 there is a upside, so there is a minus, so you are going upside, so there is a minus, so upside means minus, so P1 minus rho of 1, so density of this fluid into g into distance of this, so y1. Then you directly go to this point and going downwards, so this will be positive, so rho of mercury g into y, so y is the distance, plus going downside, so rho of water, rho of fluid 2 into g into y2, that is equal to P2. So from here you can get P1 minus P2, that is equal to rho 1 g y1 minus rho m g y minus rho 2 g y2. So in that way we calculate the pressure difference with the help of inverted YouTube manometer. So let's try to understand one question. So this is very important question. For the manometer shown in the figure, calculate the pressure difference between point M and N. So you have to calculate the pressure difference between this point and this point. So this is given in that question. So the formula will be applied like in this way, the formula will be applied. So here the pressure, that is PM at point M, now there is upside, so there is negative, so minus rho 1000 into 9.81, and this will be 6 plus 3, 9.5 centimeters, so that will be 0.095. Okay, so this there may be the correction, so this will be 0.095. meter. Okay, so next goes this point, and downside direction, that means positive. So the specific gravity is given, that is 0.83. so you have to multiply it by density, density of water, to get the density of this oil. So 0.83 into 1000 into 9.81, that is the gravity of the, this is the gravity value, and the distance, that is 3.5 centimeter. So this will be 0.035 meter. Again goes downward direction. So there is water have density 1000 into 9.81 into 0.12 centimeter. Okay, 0.12 centimeter. So that is equal to Pn. So from here you can calculate the value of Pm minus Pn. So this is the easy question. Okay, so now let's try to understand another concept. So this is the multi U-tube manometer. So this measure high pressure difference. So if there is a very high pressure difference, we can use the multi U-tube manometer. Okay, so here there is a pipeline here and pressure P1, and here the another pipeline and the pressure is P2. So density here, that is ρ1, here the density ρ2. Okay, and suppose this is the manometric fluid, all the height are given of the manometric fluid. So here there is one manometric fluid, and the density of the manometric fluid, that is ρm, and in between, so here also the manometric fluid and the density. So here there is another manometric fluid, so the density of the manometric fluid, that is ρm dash. All the dimensions are given. So here, and in that case ρm dash is less than ρm. So density of this manometric liquid is less than density of this liquid. Okay, so same way we have to calculate the pressure difference. So P1, so here there is a P1, then goes downward, so downward will be positive. So P1 plus so this is density ρ1 g y1. Okay, so ρ1 g y1, and then goes, so here the point, then goes this point. Okay, so goes upward direction, so this will be negative sign. So ρm g y2 is the distance from this point to this point. Okay, then goes so here after that, so minus ρm, so here pressure, so okay, so goes to this section. So probably this is the distance, so this point, and there is a downside direction. So ρm dash g y3. Okay, so now goes this point here, so there is upside movement, so this will be ρm g y4 minus ρm g y4. Then there is again upside direction, so minus ρ2 g y5, rho gh. So ρ2 of the density of this fluid, g gravitational acceleration, and y5. So that is equal to P2. So from here P2 P1 minus P2, that is equal to ρ2 g y5 plus ρm g y4 minus ρm dash g y3 plus ρm g y2 minus ρ1 g y1. Okay, now let's try to solve one problem using the multi U-tube manometer. So here determine the pressure difference Pm minus Pn when the manometer indicate as shown in the figure. So this is given in that question, so you have to calculate the pressure difference between this point and this point. All the distance are given here. Okay, so PM is the pressure at that point. So PM then goes downward direction, so the distance is 16 plus 20, so the distance is 36 centimeter from this point to this point, 36 centimeter. So this will be positive, because downward direction positive, into a positive 0.8. so the specific gravity is given, that is 0.8. 0.8 into 1000 multiplied by density of water into 9.81 into the height, that is 0.36 meter. Then this point is come, so here this point pressure and this point pressure is same, then goes upward direction, so upward direction that will be negative. So here the manometric fluid are used, mercury is used, so the density of mercury, that is 13600 into 9.81 into what is the distance, so this distance is the 16 centimeters, so this is equal to 0.16. so okay, then this point pressure and this point pressure will be same, so plus going downward, so that's why plus, so 0.8 because the relative density is given, the oil of relative density is given, that is 0.8. so 0.8 into 1000 into 9.81 into 0.12. okay, so this is 0.12. so 12 centimeter is converted to meter, so 0.12. okay, then this pressure, this point pressure same as this point pressure. okay, so here to here there is upward direction, means there is upside direction, so that means minus of 13600 into 9.81 into 0.15. then here to here the distance is 15 centimeter, so minus of 0.8 into 1000, because the relative density is given 0.8, so you have to multiply it by density of water, 1000 into 9.81 into the distance, that is 15 centimeter, that is 0.15 meter, so that is equal to Pn. So from here Pm minus Pn, that is equal to 38.769 kilopascal. So this is all about the multi U-tube manometer. So in that way we completed our pressure measurement chapter. So this is my handwritten notes, you can download it from the description, the link available in the description. If you have any problem, any inquiry, you can directly ask me in the message box. Thank you.